Pressure is a force that's acting normally or perpendicularly per unit area.
Okay, the definition, good. It acts normally. We shall write it later. Liz, you have to say something. Where have you ever heard of pressure?
Its SI units is Pascal.
Oh, good. Pascals. SI units are Pascals. Angel, anything about pressure that you remember?
The definition.
Yes, you define.
Pressure is the force acting normally per unit area of the surface.
Oh, good. The surface. Victoria?
Pressure is also like a measure of how force is distributed over an area.
Very good. How force is distributed over an area. The last person maybe can give us what she wants to say. And what did you want to talk about pressure, Agatha?
The definition.
Okay, you can define it.
So the
Pressure is experienced in both liquids, and say in both fluids. And solids. Pressure can be experienced in both solids and fluids. I was just asking an example. Some of you have ever gone swimming. When you go swimming, you notice that there is pressure exerted on you by that water that is above, in case you are some height below the water surface. Now that kind of pressure that is exerted on us while in water is under liquid pressure. The same time, when you are seated somewhere, most of you are maybe seated on some chairs. Your weight is distributed on that surface where you are seated. That weight or the force exerts pressure on that surface. Now, such pressure that is exerted on the surface is under solid pressure. So we are going to say, we shall first look at the pressure in solids. We shall first discuss pressure in solids, such that at some stage we shall also look at the pressure in fluids, like the blood pressure that is under fluids, because the blood is a flowing substance. Now, when we go to the pressure in solids, the first thing we are going to define what is pressure. And this definition, people have been discuss the definition. The definition is very simple. Pressure is the force acting. Pressure is the force acting normally. Pressure is the force acting normally per unit area. Pressure is the force acting normally per unit area. Now, after knowing what pressure is, we can write it in the mathematical way. Pressure is equal to force out of area. Now, that is what we shall be using in calculations. That formula, pressure is equal to force out of area, is what we shall use. This formula has come from the definition. Force acting normally. Normally means 90 degrees. Acting normally means the force we are talking about must be perpendicular. Must be perpendicular means it is 90 degrees. This symbol is for 90 degrees. So this force must be acting perpendicular to this surface. That's what we're talking about here. Sometimes you can use the word normally, sometimes normally. You can write in your classwork books. But what I will do, I will send you notes. You first get your revision book. Then when I send you the notes, you use those notes to put in your classwork book. The person who was asking, I hope I've answered it.
Yes,
Use
teacher.
your revision books, but when I send the notes, you put back. I'll send you notes which are okay, organized. So this is the formula for pressure. Make sure you have seen this formula because it is what we are going to be using in the calculations. What are the units of force? Force is measured in newtons. You remember, force is measured in newtons. What about area? Area, SI unit of area is meters squared. Do you recall that? Area is measured in meters squared. Now, when you have newtons per meter squared, it is equivalent to 1 liter or to 1 unit. What unit is that?
Newtons per meter squared.
Okay. Okay. We can just say that the SI unit for pressure is newtons per meter squared or pascals. You either use newtons per meter squared as the SI unit, or you use pascals as the SI unit. And the other time I was telling students, when you have to use pascals, let me give you an example. If I say pressure is 20 pascals, and somebody writes 20 pascals, which of the two is correct? Is it the first one or the second? Which of the two is the correct way
The first
of writing it?
The second one.
The second one.
The second.
The second one.
The second.
Okay, those ones who have one answer, who can defend her answer? Can Wendy, can you defend? Why do you say the second?
Teacher, it's
Okay, who
because
said the second? Okay.
teacher, because like in physics, the law is when you're writing any unit, if you're to write it in full form, it should begin with a small letter, and if you're writing it in like the short form, it should begin with a capital letter.
Okay, so when you're writing the whole unit, the name of the whole unit should always start with small letter. When you start with a capital letter, because this is a person, these are scientists who came up with these units. So when you start with a capital letter, there are so many passports around. So for the unit, always start with a small letter. But if you have to write this, you can write this. I can write it in a small letter, but this is not allowed. It's not a difference. The second is not allowed. This one. If you're writing symbols, we have what we call symbols and what we call names of units. These are symbols of the unit. Later, don't write like this. This is not allowed also. Capital P, small letter, but not small p. Those are just rulings of symbols. Write the entire name, write all the letters, small letters. Okay, these are SI units of pressure. Now, we are going to do some calculations that involve this formula. But before you go for those calculations, all of you must be able to remember how to convert like meters to centimeters, meters squared to centimeters squared, or centimeters squared to meters squared. Let us get an example because the work we are going to do involves those changes. Let us first revise one or two examples of how we convert. Convert the following units. Let us convert these units. For example, if I have 2 centimeters, I want to convert 2 centimeters to meters. What are we going to do? What do I do in that case? Any suggestion? Hey, class, how do you convert 2 centimeters to meters?
2 times 100.
1 meter is
Chisache, want to say something? Eh? You said
1 meter. 1 meter
Yes.
is equals to 100 centimeters.
Okay.
So 1 centimeter. 1 centimeter
So 1 centimeter
is equals to
is equal to
1 out of 100 meters.
Okay. Then, so 2 centimeters will be 2 out of 100 meters. Is it okay? If you want to put in decimals, you can write it like this. Now, I want us to convert. What if I have 5 centimeters squared? If I have 5 centimeters squared, how do you convert? I want people to convert. Everybody first convert and tell me the answer. I'm giving you 30 seconds. Converting 5 centimeters squared to meters squared. Convert 5 centimeters squared to me. Everybody do it very fast. I'll just randomly select. Any answer?
Yes.
Teacher,
Yes.
0.005 meters.
0.005. 2 zeros. Somebody has 0.005.
No,
Take 3
teacher,
zeros.
Do people agree with that answer?
No.
Like this. Like this.
No.
Yes.
No.
Okay, let us convert as a class. Let us try to convert. After converting, shall check out which one is the correct answer. Remove me. Which one have you got? Listen. Okay. So 1 centimeter is equal to 1 out of 100 meters. Now 1 centimeter squared is the same as 1 out of 100 times 1 out of 100. These are 2 of them, meters squared. Okay, this is meter and this is also meter, and centimeter squared. It is the same as 1 out of 4 zeros. So if it is 1 out of 4 zeros, when you are converting, you don't have to go through this step. You just go to the direct step. Just because I'm doing it like this to help you remember. So 5 centimeters will be the same as 5. You divide by 4 zeros. 1, 2, 3, 4. So this one gives us 0.005 meters squared. Make sure you are understanding how we are converting, because when we start the calculations and pressure, they will give us items in centimeters and they require us to put them in meters. So you have to remember what we are doing. Any question so far? Any question about converting? Okay. This was fluid living. A flow measures let us work out this number. Let us work out this. We are working out this number. Somebody was asking what is pressure, first concentrate on this. You will see it after, because it's not pressure. This is measurements of senior one. We are just revising it. Before we start the calculations, so we are giving ourselves 1 minute to get the answer for this. Remember, we are doing this to help us be keen with what we are going to do in the next part. Yes?
I was asking which sentence
Somebody
is
is
that
asking
calculate? Chat's not clear.
its area. Calculate its area. Have you had it? Calculate its area in Roman 1 centimeters squared, Roman 2 meters squared. Lisa?
Roman 1, I've got 400,000 centimeters squared.
Okay. Leila, Ali, Leila, what have you got in Roman 1?
Teacher, I haven't yet calculated.
Ali?
Yes?
Okay, Chiza, Josephine. Chiza, Josephine, what answer have you got? Samantha? Hey, yeah. Bazira is asking, can they ask you to convert centimeters squared to meters? Now, centimeters squared to meters, this one they cannot ask you this because these are different dimensions. In science, we call them dimensions. So this one they cannot ask you, but they can ask you to convert centimeters squared to meters squared. They must be the same, squared with squared. Lukwago, what answer have you got?
Teacher, I've got 40 meters squared.
40 meters.
40 meters. Okay, Shahida.
I also got
Shahida.
40 meters squared.
Okay. After getting those answers, let us work them together and see if our answers are correct. After working them these ones, then we shall go straight to our topic of pressure. We shall get questions under pressure. The first part was asking, So solutions for part one. First of all, area is equal to length times width. That we say 500 by 800. These are how many zeros? 4 zeros, eh?
Yeah, 5.
4 zeros or 5 zeros? 5.
5.
Then the units are centimeters squared. That is part A. Now part 2, we have just said, when they ask, by the way, there are two techniques of working out this number for part 2. Part 2, one method is, you can either convert each of these separately. When you convert each of separately, for example, I can say, if length is 500 centimeters, I divide it by 100 to get 5 meters. Then the width is 800. If I divide it by 100, I get 80 meters. Now I can use these. I can say area is length times width, which is 5 times 8, and we get 40. That is one way. One way is first converting each one of the figures to the units, then you multiply. Then the other way is getting this answer that we have already got, this one. Or we can just get this answer. Answer is 400,000. Then this one, the 400,000, you divide it by how many zeros? We said you divide by 4 zeros. 1, 2, 3, 4. When you divide by the 4 zeros, again, you come to the same answer. So there are two methods. It depends on which one is easier for you. Either first converting and multiply, or you first multiply when they are in their original units. Then after you convert. Which of the two is easier for you?
The last one.
The last one.
Both.
Okay, preference we'll check. Let us now go to the calculations. So examples. We are getting examples now under pressure. Examples.
Network,
Teacher.
Yes.
Who's supposed to work out?
Teacher.
Yes.
Teacher, is the force or is constant?
Like 10.
Yes.
It can be any figure. It's not constant. It can be any figure they want.
Teacher,
Yes.
are you supposed to change centimeters squared to meters squared?
Hey, that's what we have been doing. That's why we first did the other first number, the other numbers of converting. Because the units must be meters squared, SI units of pressure, of area.
Thank you.
Who brings our food?
Students.
Okay, somebody has some answer. So we have number 3, a box of mass of mass incidence on the table. So you work out that number.
Yeah, guys, don't go in there. Should I
Some
get
answers
287.5 pascals?
280.
7.5 pascals.
27.5.
187.5.
Somebody has 187.5. Any other person?
Yeah.
Teacher, I also have 187.5 pascals.
Okay. Let us check. Others, work it out, 1 minute. Take your time, don't rush, but you should be understanding what you're doing.
May I have 75?
For you have what, 70?
75.
Okay, somebody has 75. We shall cross-check. We are going to work it out together. We'll check which one is the right answer. Christine, you have some different answer?
No, I have the same.
Okay, we have
187.5.
187. Okay. People like Rhoda, they can't hear.
Teacher, I have 18.75.
Okay. Zoe Tushabe, what's your answer? Tushabe Zoe, what's your answer? Wanyoto Lona, what's your answer? Walda, what's your answer?
18.75 pascals.
Okay. Somebody who's using Techno CX Air, can you rename yourself? Put there your right names, your two names, Techno CX and Techno F1. Please rename yourselves. We need to know people we are discussing with because we are taking screenshots. Okay, let me cross check here. Okay, can we now work it out together? Okay, give solution. What do you pass out of area? pressure is force out of area. But now in the question, they have given us mass instead of force or instead of weight. Because if they put units of force, if they put newtons, then that is force, even if they use the word weight. But now they have put kilograms, meaning they have given us mass. How do you change kilograms to newtons?
1 kg.
How do you change mass to
kg
force?
is 10 newtons.
1 kg is equal to 10
Newtons.
newtons. You should always remember that. Therefore, force will be 15. Okay, we just use this formula. We say it is mass. This G is the, okay, I think I'm not like G, but G is acceleration due to gravity, which is this 10. So every time they give you figures like that, you just multiply. In other words, you multiply your kilograms times 10. Kilograms times 10 to get this. So the answer we have here is 150. That is not the final answer. Here we are just converting to SI units that we want. We are converting kilograms to newtons. To convert them, you just multiply by 10. Now that is one part. The other part is the area. What about for area? Area is 80. I can just do like this. 80 and 100. I can just do like that. For this case, what do I get? This 0 goes to this, goes to this, this goes with this. So end up with 0.8. That is area. Now after getting area, I can now comfortably go ahead and get the pressure. So you always first convert to the units they want, then you go to the formula. So pressure is force out of area. So for those people who divided, what do you get when you divide this?
187.
187.5.
187.5.
So that's how that answer was supposed to be got. For those who got a different answer, what were the mistakes that you had?
We didn't change kilograms to meters.
Okay, so next time you have to always convert. You have to be careful with the question.
Multiplying.
In that question, if they give you kilograms, that's when you multiply by 10. But if they give it as newtons, then you don't multiply. It's already in SI units. You just have to be careful. Am I given SI units or I'm not given SI? Because some people cram that whenever they give us a figure, we need to convert. Be careful, which one have they given us? Okay, now that one leads us to this. Let me give you a sample box and you tell me what will happen. If I have a box like this, now we are going to look at maximum and minimum pressure. Maximum and minimum pressure. If you look at that box, what of its sides, which of its sides is resting on the floor? What is the area that is resting on the floor? If you look at that box, is it, by the way, how many areas do you have? In this box here, let me say area 1, area 2, area 3. This is length, this
Have
is
enough
width,
area.
and this is height. Length, width, and height. So which areas can we get from this box? We can have length times width. Any other area?
Width times height.
Width times height.
And height. Any other area?
Length times height.
Length times height. Distance. Oh. Okay. Area 1, area 2, and area 3. Which of those areas is resting on the floor? If this box is resting on the floor or a table, which of those
Area 1.
is resting?
Area 1.
Area 1. Because it's this length and the width that is resting. Now, what if I have this box like this? The same box. If this same box is like this. For this case, now the 20 is here. This was 15. So for this case, which area is resting? Is it area 1, 2, or 3?
Area 2.
Area 2.
Area 2.
This is width and this was the height. If I want to ask you a question, in these two diagrams, where do you think the box is exerting more pressure on the ground? Where does it exert more pressure? One is in case, this is case 1.
Area 1.
Area 1.
Case 1, this is case 2. Let us call. Is it case 1 or case 2? Where is it exerting more pressure?
Case 1.
Case 1.
Okay, what we are going to do, let us get the two areas and compare. Let us calculate the two areas. We shall calculate the pressure, not areas, the pressure. So for case 1, let us say case 1. Pressure is equal to, what is the area? Oh, let us say the box has, consider the box below. Let us give it mass. Of mass 20 kilograms. Of mass, let us say mass 2 kilograms. We have given the box mass 2 kilograms. So for case 1, that force, we have been saying the force always get the kilograms times 10, 20 newtons. Our target, what we are trying to check, we are trying to get the two answers, the pressure in case 1 and the pressure in case 2, and compare the two answers. We want to see of the two answers of pressure, which one is more than the other. Nora, you are saying something? Issa, Chisingo, Issa, your hand is up. Raina, your hand is up. Any question? Christine?
I just spoke.
Christine? Nabweteme, I see your microphone is on. Any question? What I'm saying, okay, someone has said I don't understood. Now we have these two terms. We have maxima and minimum pressure. Maximum, you see the same box. This speaker here. This speaker can be like this. At the same time, the speaker can be like this. You see, there are different situations. I can have it like this, or I can have it like this. The same speaker, the same weight. Now our question is, in which of the two situations does the speaker exert a lot of pressure? Does the speaker exert more pressure? Is it when it is lying horizontal like this, or when it is vertical like this? Is what we are trying to calculate, and we have said.
It's lying on the ground.
You did what?
When it's lying on the ground.
Hey,
when it is exact.
Okay, that is very fine. What we are going to do
has
is
more pressure in case 2.
Okay. Let us now calculate the two answers and compare. So I told you our box has mass 2 kilograms. So in case 1, force is mass times G, 2 times 10. We said G is always 10, 20 newtons. And the area, in case 1, the area on the ground is 20 and 15. The area, this gives us, what does it give us?
300.
300 out of 4 zeros. Oh. So 0.03. That is the area. So the pressure, force out of area. Pressure is force out of area. So the force is 20. Area is 0.03. What do we get? What do we get for this case? People with calculators, what do we get?
666.67.
We can round off.
667.
That is the pressure for case 1. Pressure for case 1. Now we want also to calculate the pressure in case 2. This one, when it is vertical. Then those two answers, we shall compare them. Now in case 2, pressure in case 2 is force out of area. The force is the same, 20 newtons. What about the area?
0.015 meters.
0.015. What answer do you get? This is case 2, remember. What answer do you get?
1,000.
When you divide, what answer?
1,333.333.
1,333.333.
Okay. So we have something like, now of the two answers, which one is greater? Is it answer in case 1, answer in case 2?
Answer in case 2.
Answer in case 2.
Answer in case 2.
Now somebody should have now noticed If the other answer is greater, what is the difference in the two answers? How the way we have gotten the answers? If you look at this area, look at the force. The force is 20. Even here, the force is 20. So the force is the same. But what has caused the difference? The difference is in the area. If you look at this area, this is 0.015, but this area was 0.03. Which of the two areas is greater?
0.03.
0.03.
You now notice that a big area gives us a small pressure. The conclusion, a big area gives a small pressure, but a small area, this small area gives us a big pressure.
The bigger the area, the smaller the pressure. And the smaller
Very
the
nice.
pressure, the bigger the area.
That is good, Sarah. The bigger the area, the smaller the pressure. And the smaller the area, the bigger the pressure. Therefore, we are going now to come up with our formulas for maximum and minimum pressure. That's how we come to maximum and minimum pressure. How are we going to write them? We are going to say that maximum pressure
is equal to
maximum pressure. Let me write it like this. Maximum pressure is always equal to force. Force is the same. Don't say minimum force. Our force is the same, but down. If I'm to get maximum pressure, then down I should put minimum area. So maximum pressure goes with minimum area. If you're working on those numbers, then let us also write the other one. Then minimum pressure is equal to force
Out of maximum area.
out of maximum area. So that's how we work out. I mean, those are the formulas for maximum and minimum. Now I'm going to give you a question to try for me using that information. So example, you'll be copying that information because you need it. Example, a box of mass 30 kilograms measures 30 kilograms, a little bit big. 3 kilograms measures 20 centimeters by 2. So that is the question. There is a box of mass 3 kilograms, but measures this 30 centimeters by 20 centimeters by 15. Length by width by height. These ones. Now they are saying calculate the maximum pressure and Roman 2 the minimum pressure. So you copy that question. I'll be sending work the Google Classroom and on the page, on the platform. When this lesson has been recorded, use it for like I told senior twos yesterday. I have noticed senior twos don't know how to subscribe on a channel. How many people know how to subscribe on YouTube channels?
Me.
How comes when you watch the videos you don't subscribe?
They don't want.
Just because they don't want.
Subscribe because I need 1,000 subscribers in 2 weeks. 1,000.
I can pay you.
For money.
What's money?
Once you get a blue tick.
That word of subscribing is always at the bottom. Where the video, there's some button that has red. Subscribe. I wish I could get it. People don't know.
No, it's not just that you don't want.
We know, but you don't want to subscribe.
No.
You can't just watch our videos before subscribing.
We don't want.
We
You
don't
watch
want.
our videos for free.
Mungu, you become a celeb.
You want but you don't know. You want but you don't know.
The things are boring.
You don't know.
We know.
I'll share a video to help you know how they subscribe. Please, you subscribe today. I'm going to put this video there.
We know.
We don't want.
We know more than you know.
Me.
Okay, for this question, how do you get maximum pressure?
Just subscribe. The channel is boring.
How do you get maximum pressure for part 1?
What happens?
Yeah?
In the post.
When we subscribe, what happens?
You get notified every time they
Yes,
post.
very nice. You get notifications.
Don't want them.
But you can subscribe.
Teacher, they first
The
have
bell.
to tap the bell.
Bad notifications.
Okay, for such numbers,
500.
one of the simplest ways is to first get all the 3 areas. And out of the 3 areas, you check the smallest area and the largest area. That will be one way. For example, the length was width, 30 out of this, 20 out of this. Then I can say the other area can be length times height, 30 out of this, 15 out of that. Then the other third area can be width times height, 20 out of this. So out of those 3 areas, you check which one you are going to use when you are working out maximum pressure and which one you shall use when you are working out minimum pressure.
Why are the areas out of 100?
If we are converting centimeters to meters, you don't forget that part of converting centimeters to meters. You have remembered?
Yes, Monsieur.
Bonjour.
Not French.
Okay.
French.
By the way, after what lessons are there?
Languages. So many things.
Before you left, you had already selected your languages.
Yes. No, we haven't.
Yes.
Yeah. In those languages, we shall put her. Now you are going to disturb us after break because we are going to put what we call break-up rooms. Each person will be going to her subject. So what
How? But we didn't select. Yeah, how?
That's how it is.
Next ringtone.
We shall show you what is the answer to this.
iPhone to food defect.
Does you mean you
500.
Then this one is. This is your point.
0.03 cents.
meter squared. So
0.03.
0.03.
This is 45.
0.6.
It's this.
Teacher, area 1 is not 0.03.
The first
Area
one
one
is
is 0.6.
0.06.
0.06.
Yeah.
The second
0.045.
then this one is
0.003.
We don't understand.
0.03.
1,000.
Ja, please explain again.
Well, now we are doing this. This is calculated. What do I need to explain?
Are you breaking?
This is calculator work. Do you have a calculator with you?
We can't hear you.
Well, these are not the answers for the question. These are just areas, and out of these areas, we are going to cross-check which one is the smallest area and which one is the largest area. Because in the formula for pressure, for example, maximum pressure, which area do we use? The smallest or the largest?
The
smallest.
Maximum, we use the largest.
Maximum
Teacher
pressure.
stated that maximum use the minimum area.
For maximum pressure, use smallest
area.
This is what you have said the other time. We said the maximum goes with smallest and the minimum goes with largest. So what are we going to put where there is force? What we substitute for force?
20 newtons. 20 newtons.
Because the dollar is 2 kilograms.
30. Yeah, 30
newtons.
30
newtons.
Was clear?
Yes.
So force is this. So we shall put 30. Out of our areas, out of the 3, A1, A2, A3, which of the 3 is smallest?
0.03.
0.003.
So we shall put here 0.0. But how do you put your smallest out of the 3? What do we get?
1,000.
1,000.
1,000 newtons. You can either use pascals or newtons per meter squared. So maximum, I repeat, maximum pressure goes with minimum area.
We get 5.
So everybody can catch it now, the minimum pressure. This is part A.
500.
So minimum pressure is equal to force out
Out of the highest area.
yes. What is which one is the largest area from the 3 areas?
0.06.
0.06.
Okay. 0.06. And this case, the answer we get is 500.
Excuse me, teacher. You wrote 20 as the force.
Hey, it should
You
be
wrote
30.
20 as the force. It has to be 30.
Okay, sorry.
Get 500. The answer.
The answer is 500.
The answer is 500.
500. 500 pascals.
Yeah, 500 pascals or 500 newtons per meter squared. So class, that is how we calculate numbers that involve maximum or minimum pressure. I hope class has understood.
No.
No.
Which part haven't you understood?
Why is there a negative on the 2?
I have not understood.
Negative on that 2?
They have.
Which negative?
The one where it
Eh?
has newtons per meter squared.
Supposed to be newtons out of meters squared. Now in science, you can write this as newtons. You can put like this, by the way. You can put a forward slash. Or you can write any, then you write small n, and you put a negative 2. A negative 2 means this one was down. The m was down. Eh? But when you put a slash, don't again put negative. Don't do double. When you put a slash, leave it as positive. If I don't put a slash, then I put negative. It's just different ways of writing a unit. Instead of writing it like this. Is it clear?
Yes, teacher.
One was asking the negative. Is it clear? Any other question? Yeah. Remember, I'm going to send my works questions on the page. You should work them out. Any other question before we leave the classes? We have 3 minutes to close this session.
Yes, teacher.
Yes, Sarah.
So how come when we're finding the maximum pressure, the smallest area we use 0.03 instead of 0.045?
At 0.03 and 0.045, which one is smaller?
0.03.
Hey, and first we say we have three areas. Out of the 3 areas, you pick out the smallest, and the smallest is this.
And then the biggest.
When you're looking for minimum pressure, look out for the biggest. This one we're not using it anywhere. We're not using it because it doesn't fit in any of the formulas.
Okay.
Teacher, when are you uploading the work?
You look at these ones.
After the lesson.
What was your question?
When are you uploading the work?
When are we doing the
work? I'm uploading immediately after this lesson. In the next 5 minutes, the work will be there.
Okay.
In the website.
Some of us don't
The work is on the
classroom.
Teacher,
you don't know how to get the Google Classroom. I will first put it on WhatsApp. Are you on the WhatsApp group?
Yes.
No.
Yes.
No.
I'm not. No.
Some of us are not.
Some of us
We are. Some of us are not in our.
Somebody said a closing prayer.
Amen.
Amen.
When are you uploading the work?
Baby girl, I have said immediately after the lesson I'm uploading. Okay, Kali. Having understood this topic, I'm going to upload, and I request that you do the work. When you do the work, you can inbox me on my WhatsApp, in that I can help you mark that work. You shall also put it in the Google Classroom. Someone is asking, where do you put the work? We are using your revision books.
Some of us are not on Google
So we don't have your WhatsApp.
WhatsApp number.
My number, you are going to see the number when I upload on the WhatsApp page. You see the work, the person who would have uploaded is the one. There is a stop clock.
Okay.
There is a stop clock on my profile picture.
Okay, teacher, we have understood.
Ale musule bulungi.
Uganda.
Once again, hey guys.
I'm closing the meeting anyway. Don't wait for the next lesson.